Well, there we are, almost totally put together. There is a hopper to go on here, but I've had some problems with it, saying it's not waterproof, the part. Even though I've tried some repairs on it, I've got other repairs to try on it. This is the wear plate here. I haven't put all the screws in. Bolt missing off here as well, but I think that should be strong enough. So there's these saw blades, and this is the switch I was on about. So one way is like switch on forward, and the other way is like a temporary switch on. Sometimes let go, it stops, like reverse. That basically just swaps the two wires over inside the switch. I'm only using 12 volts here. This is 24 volt motor. This bowl, I have a bowl under here to catch any stuff that makes. As you see, it's empty there. Well, a tiny bit of what I'm going to call crumbs in the bottom and corner. You mightn't see them, but nothing to write home about there. See, I've got a new board here. The other one was getting very tatty with different motors being bolted on and such like. Right, I'll get this going. I'm going to hold a piece of plastic. I would like to have the hopper on here for safety. I think it is a bit safer with a hopper on. But I'm just going to hold the part. It was a mole wrench, which I showed you earlier, against the blades. I will see if it shreds, cuts, whatever. Unsure of the gaps. There's only a 1mm gap really, using those spacers. Well, look on the back end of this, I'll show you the spacers, how this was basically put together. So there's those saw blades there, 4.5 inch I think. Right, let's get some plastic and see if it'll cut it up for us. We'll shred it up. I'm expecting almost like sawdust, so it might be quite a bit finer than the previous iterations I did with this with cutting blades. This is bigger diameter, these blades. Okay, enough waffle, let's get on with it. Okay, I'm going to see what happens when I put this bit on. This is one of the earlier sort of connection pieces in iteration that connects from this side. Don't think I had the e-bike motor then. So such and such a. I'm going to hold it in this hand vise, a mole wrench as I always call it. Okay, let's get on with it. So we have the forward, off, and reverse is just like a short bit. That's just if it gets jammed in, basically. 12 volts here. This is a 24 volt motor. Looks to me like one of those, at least one of these cutting blades, these saw discs, is not gripping. Well, not totally gripping, it seems to be slipping every so often. I only other one I was having to push very firmly, about 2 to 4, 5 pounds, so just a couple of kilograms, maybe a bit more pressure on it. I'm going to try this a bit lighter. I'm not pressing at all much at the moment, very light. You see that is cutting through that quite well. I think that is certainly better than the cutting blades I used in my other iteration, sort of this all prototyping here. So I'm trying to push this way a bit, as if to saw it. Yep. Let's have a look. That's only been a few. A few moments there, but that seems a lot better than the. So turn that off. Make sure the power supply, 12-volt power supply using. I'll look on there. Yep. I thought it might be a lot finer than the cutting blades, but I reckon it's about the same consistency here. So there's a look underneath. And I'm going to continue on a bit. I seen that was quite quick, and I was trying not to press quite so hard as with the cutting disc, splitting discs I was using on the previous prototyping of this. I'll have to switch the power supply on. Pressing quite well, just open away from all the plastic so that touches. I reckon I'm using about up to 2 pounds of force there. That'll be about 1 kilo, I think. Again, the blades are trying to push this over this way, and let me turn that off. Just want to show you something. This is one idea behind this separate plate here. You can screw off. Obviously, if you have the hopper on, you have to take the hopper off and this plate off. And we just pinned out this plate because it's already getting a few scratches on it there, but not too bad. But it's what I term as a wear plate, so that's easier to replace. The gaps here are quite wide on each side because I'm not sure the distance of these blades. These are 1mm apart. Well, I've got 1mm like plastic printed washer in between each blade. Just keep watching this video to show about putting it together. So here I'm trying to push more, well, pressing down a little bit, but trying to push more this way. See, that's cut that chunk out there. Jump there. So gradually I'm rotating this towards so. There's some friction here. I can smell the plastic. Like, not totally melting, I don't think, but not far off. Right. Let's try something a bit more square than this round bit. Let's turn the power off. Okay, I'm going to try cutting particularly this side here. This is like an iteration of one of these. Right, let's go for it. see jam there. Jamming a bit more here. So here I'm trying to lay it at a bit of an angle like this, and then start pushing on it forward, kind of like rotate. Quite lightly, and in the cook direction that you wouldn't have a piece of wood and set a saw blade. Jammed. Obviously what we want is like probably a biggish hopper, high hopper. Put parts in and the weight of those parts will push down onto the blades. So we are getting a bit of plastic jammed between the blades there. That's probably quite easy to get out or just leave it. Right, that's a much better success than you can see the stuff under here, but I'll show you now. Just now when I turn this power supply unit off. Some bigger clumps there. Not bad for prototyping. I think that would, well, most of that would go into a sort of homemade do-it-yourself film and making machine sort of thing. Melt it down and squeeze it through a small orifice basically. Is there anything else I can say? Let's see if we can get any of these particles out with this. This is like a golf brush, I believe, or brushing golf balls. So the power, it's unplugged here. Don't worry, I can grip this connector bits. Basically turn the blades by hand. Yeah, some of it's coming out. I think pushing another piece on will push this out, so to speak. try a screwdriver. Let's see about, talk a little bit about putting it together. I'm using these like saw blades that came in this packet here. Has it got any details on there? TCT circular saw blade. These are 4.5 inch, 22.23 millimeter bore. That's the hole inside there. 40 teeth. Warning about the speed there. Okay. And in between each one I've printed out these are 1 millimeter thick sort of washers and waste spaces. That's in between each blade. I've put some on here already. So that's a 22 mil bolt, and using this bearing, well, one of these bearings here, put some details, bit of plastic on that because that's been used. Couple of nuts there, they're going to be locking nuts. What I found on one of the previous ones I did with the cutter blades is that I think this bolt was turning and it was gripping against one of the cutting discs and turning the single nut I used to have, but now I'm going to be putting 2 nuts on. So there's a washer on there already, and I'm putting them on like so that'll, well, from this direction it's going to rotate as you're looking at it clockwise, but it will be anti-clockwise to a certain extent because it will be turned facing the other way. And washer on, blade on. Be careful with these blades, they're sharp. And this side piece, well, 2 nuts on first. I'm going to tighten these up against each other, then put almost, these are half nuts, 22 millimeter half nuts. Put tighten those up quite firmly using a mole wrench. That's a hand vise. I generally call these mole because that is the make of this one. Mole. Had these many years. These clip on things. I'll screw those down a bit by hand and then I'll come back. Okay, they're just hand tight. That's just so I can, is it in the middle? Yeah, a little bit this way towards the camera. Want these central, so I'll loosen these ones off a little bit this side and then tighten those up about that side. I reckon that's, I'm just looking at the gaps. Is that pushed all the way? I'm just looking at the gaps on each side of the nut here to gauge whether it's central or not. Want it reasonably centre, and I'm not sure of the spacing here, I'll be honest. This is prototyping. Let me have a look at this. And there we are. I did notice when I was going to tighten them up that one of the blades was facing like the opposite way to what I want. So put that bearing on there, line it up a bit, push it in a bit there. I want to tighten this nut up here. So I'm using this nut to tighten up and push this bearing into this recess sort of thing here. slacking it off a tiny bit so that it can roll very easily, and then putting another nut on there to lock it off. Tighten those two up against each other and come back. I'll show you that spins quite well. So it should be turning anti-clockwise when I put positive into positive in the e-bike motor that I've got. And this is like a connection piece, in case you haven't looked at the other videos. So it's got shape there for the head on this bolt, goes on nicely, and there's like a sprocket on the e-bike motor. I'll show you that just now. But first of all, I'm going to get at least 4 bolts in the corners here. These are 130mm by 6. Let me check that. I think it's 120 by 6mm bolts, these. Oh, let me check. I'll pour washer on first. And I'm going to be using nylock nuts. And it does want to go on this way because the motor housing and supports are all here, and it'd be hard to get in at the bolts if you put them on the other way around. Found that out in the other shredders I was making. I'll continue on there, put some washers on there and some nylock nuts on. There's what I call a wear plate to go in here, which gets bolted down with some countersunk screws and a hopper. But the idea of the wear plate is that if this gets worn out, it's easy to replace just that part and put a new wear plate in. Okay, I'll put these bolts on first and tighten them up. So here is the e-bike motor with the sprocket on. That just fits in there. There's a connection, and there's a bracket for it here. There's my grandson coming on. I put some details. Pretty hefty, this. Powerful. I'm going to be running this off 12 volts, at least initially. But basically that has to, I'll need a new wooden plate. My old one has had it. This needs raising up a bit. But that plugs into there, take my word for it. And I have this two-way sort of switch. So that's for reverse. As soon as you let go it releases, so you won't want reverse much, and forward it stops on, and obviously off in the middle. That's just a two-way switch in a box. That's all to go on to a piece of wood, which will have a hole cut in for the filament to drop through. Well, not filament, the particles of plastic, if this works at all. So if you look at my other videos, I tried some cutting discs. I tried various motors. This has been the best motor so far. It's gear reduction, 300 to 1 I think it is. It's near enough 3000 RPM, and 10, it's near enough 10 to 1. So that's about 300 RPM by the time it comes out, and the reduction obviously gives it a lot more torque. That's off 24 volts. I'm using this off half voltage, so it might be about half the speed, about 150 RPM when I do it. So I'll get all this connected to a big piece of wood. I have to cut to size. My old piece of wood has been used so much, I'm having to cut a new piece just from a piece of shelving. Then I'll come back when I've done all that.